All right, let's just jump right in with a pretty wild idea. What if the very thing you trust to save you from a fire could actually make everything a whole lot worse?
I mean, really let that sink in. The tool you grab in a panic could be cooking up a lethal chemical weapon right there in the flames. It sounds crazy, right? But this shocking idea is exactly what we're digging into today.
And it's not just a one-off thing. These aren't just weird exceptions. They're paradoxes that actually teach us something really important about the chemistry of fire itself. So to really get it, we've got to go back to square one. What is a fire anyway? And that question brings us to a fundamental concept, a model that pretty much every firefighter and scientist uses to understand fire.
You know, back in school, you probably learned about the fire triangle, right? Fuel, heat, oxygen. Simple enough. But it turns out there's more to the story. Modern fire science adds a fourth piece to the puzzle, turning that triangle into a tetrahedron. And believe me, that fourth side, it changes everything.
So, what's that fourth side? It's the uninhibited chemical chain reaction. It sounds complicated, but think of it as the fire's engine. It's the self-sustaining process that keeps the whole thing roaring. So, to kill a fire, you just have to take away one of these four things. Get rid of the fuel, cool down the heat, cut off the oxygen, or, and this is the important part, break that chain reaction. Once you get that, you'll see exactly why some of our early fire extinguishers were, well, kind of a disaster.
So let's take a little trip back in time and look at a couple of these old school extinguishers, the ones that got pulled from the market for some really, really good reasons.
Now, when you look at how they worked, they actually sound pretty smart. The carbon tetrachloride one, it hit two sides of that fire tetrahedron at the same time. And the soda acid type was basically a self-pressurizing water hose. But here's the thing, both had these massive hidden dangers. The soda acid ones could literally corrode from the inside and explode in your hands. But the problem with carbon tet, oh, that was way, way worse. And this wasn't an overnight fix. Look at this timeline. It took decades of accidents and a slow, dawning understanding of the chemistry before people finally went, whoa, this carbon tet stuff is seriously dangerous. And it wasn't until 1969 that those explodable inverting types were finally pulled for good. So here's the absolute kicker. The heat from the fire itself would break down the carbon tetrachloride and reform it into something else, Phosgene gas. This is the same stuff used as a chemical weapon in World War I. So imagine this. You successfully put out a small fire in your garage, feeling like a hero, but you've just accidentally gassed yourself in an enclosed space. It's horrifying. Okay, so just when the industry started to figure out and fix those old problems, progress threw a whole new curveball at them. We started using new materials that created a whole new kind of fire, one that basically fights back with its own chemistry. Yeah, we're talking about Class D fires. This is when metals themselves start to burn. We're not talking about wood or paper or greasier. We're talking magnesium, titanium, lithium. And these fires burn at insane temperatures. The chemistry is just on a whole other planet.
And this is where everything you think you know about fighting fires goes right out the window. Your first instinct, my first instinct, anyone's first instinct is see fire, get water. But with a metal fire, that is the absolute worst thing you could possibly do. So why is that?
Well, it's pretty mind-blowing actually. A burning metal like magnesium is just so incredibly hot and it's so desperate for oxygen that it will literally tear water molecules apart just to get at the oxygen atom inside. Think about that. The fire is so powerful it just rips H2O to pieces. So the fire steals the O from H2O. What's left? The H2, pure hydrogen gas, which, as you might know, is incredibly flammable. So by spraying water on this fire, you're not putting it out. You are literally feeding it fuel. You're turning a bad fire into an explosion. All right, so water is a big no. What about a standard CO2 extinguisher? That just suffocates the fire by pushing out the oxygen, right? Nope. A Class D fire is so hot, it does the same exact thing to carbon dioxide. It breaks apart the CO2, steals the oxygen for itself, and just keeps on burning. This is when you realize this is not a normal fire. So, you can't cool it with water, you can't smother it with CO2. What on earth do you do? Well, you have to fight fire with chemistry. You have to use an even smarter, more advanced chemical solution to beat this thing. This is where Class D extinguishers come in. They use these special dry powders, and it's honestly genius how they work, because they attack multiple sides of that fire tetrahedron all at once. You apply the powder, and it melts over the burning metal, forming this airtight crust.
that smothers the fuel, cutting off the oxygen. At the same time, that powder absorbs a ton of heat, cooling things down. And by creating that physical barrier, it totally breaks the chemical chain reaction. It's a triple threat.
And that right there is the big lesson, isn't it? Fighting fire isn't just about spray and pray. It's not one size fits all, it is all about chemistry. And we learned, the hard way, that you have to perfectly match your weapon, the extinguishing agent, to the specific chemical reaction you're trying to stop.
Now, it's easy to think, okay, that's cool for scientists in a lab, but what does it have to do with me? Well, this super specialized science is actually more important in our daily lives than it has ever been.
Just think about it for a second. What's in the battery powering the device you might be watching this on? Or an electric car? Lithium. What about the lightweight alloys in modern cars and airplanes? Magnesium. In all of these areas, grabbing the wrong extinguisher isn't just a mistake, it could literally cause a disaster.
So, the next time you see a fire extinguisher on a wall, maybe give it a little nod. Because it's not just a red can full of stuff. It's the product of more than 100 years of science, tough engineering, and frankly, some tragic lessons. It's a powerful reminder that real safety, it isn't just having the right tool. It's about knowing the science before you ever have to pull that pin.